Okay. All right, so today will be partial fractions. And it is the 7th. Really is frustrating how long it takes to get competent with your left hand, even remotely, but because it still feels so unnatural, even after all this time. But I'll just press on. Let's see now. All right, so two x take 1 equals a times x plus 3. Plus b times x take 4. So let x be -3, then that will disappear, and that will mean that -7b is equal to -7. So b is equal to 1. And let x equal 4. Then that term disappears, and we have 7a is equal to 7. So a is equal to 1 as well. Right, for question 2, we've got to express that fraction there as a partial that rational expression as partial fractions. So let's see. So we do much the same thing as what we just did. Imagining that there is an a over x at 4 and a b over 2x take 3 on the other side, the right hand side. And so a rather 4x at 5. We set that equal to a times 2x take 3 plus b times x at 4 let x equal negative 4. That latter term disappears. That turns into negative 11a equals negative 11. So a is clearly equal to 1. And for x equal to 3 over 2, that disappears. Then we get 5.5b. 5.5b is equal to 11, and therefore b is equal to 2. So, to be explicit about it, although I won't for future operations, we can just say that 1 over x at 4 plus 2 over 2x take 3. Like that. And for b, part b, well, we have much the same thing going on. So I won't do this last step. So I should just say negative 7x take 7. Is equal to a times x take 2 plus b times 3x at 1. So let x equal to 2. First term disappears, that turns 7b. 7b equals minus 21. So b is equal to minus 3. And let x equal negative 1/3. That disappears. That turns into minus 5/3 of A on the right. Well, I should keep track of this then. 7/3 takes 7 is 2 1/3 takes 7. 2 1/3 takes 7 is minus 4 2/3. So minus 4 2/3. That's what I calculate the left side to be. Okay, on the right side, minus 2 1/3. Right, okay. I get it now. So A is just simply 2. Okay, C is just much the same. So we'll try D. Can start to be a bit more selective now. So we understand it'll be 5x over x at 3 times x take 2. All right, then your 5b is equal to 10, so b is equal to 2. Equal to negative 3, then we get negative 5b, no, so rather negative 5a is equal to negative 15. So a is equal to 3. Gotcha. And now these as partial fractions. Well, we have a squared linear factor on the denominator. Squared linear factor on the denominator. Now, how do you do it? Well, you kind of, well, okay. I'll just show you. 2x add 2 over x add 3 all squared. You set it equal to a over x add 3 plus b over x add 3 squared. Right? So yes. Now, what does this mean? Well, 2x add 2 would be equal to a times x add 3 plus b. So a must stand for 2 and then we have a 6 on the end, but we need to turn that into a 2, so b must stand for -4. Okay, that's good. Now, what is part B all about? Well, you would turn it into 3 partial fractions. So I'll show you what I mean. -18x plus 14 all over 2x take 1 squared times x add 2 and set that equal to a over 2x take 1 plus b over 2x take 1 squared plus c over x plus 2 and then so that means -18x plus 14 would have to be a times 2x take 1 times x plus 2 plus b times x plus 2 plus c times 2x take 1 all squared. Now let x equal -2 and that will disappear, that will disappear, that will stay, that will turn into -5. So 25c is equal to 50. So c is equal to 2. Then what do we say then? Then let x equal to 1/2. Then on the right, that disappears, and we get 2.5b is equal to 5. So b is equal to 2. And we can't do that anymore because now we have to figure out what a is. Don't we? Well, if I expand this out, I'm going to get a times 2x squared plus c times 4x squared, but I already know that c is 2, so it'll be 8x squared. And I know that that's equal to 0. So a must be -4. And that solves that one. Right, so check. So that's kind of enough for today, right?